Okay, so this is the problem that I gave you on your haiku that's due today, and this is a tricky one, and there were some errors that I have to go over with you from the textbook. So just hang in there, but see if this will help. You know, volume's just a tricky topic, but this is the picture, the first picture on the haiku that you should have for today. Uh, and they ask you to find the volume revolving around four different lines. So the first one is the volume around the x-axis, and that is a traditional washer, okay? Because when you revolve it around the x-axis, you're getting, you know, kind of that shape here that you're getting, okay, at three-dimensional shape. And that's a traditional washer. The limits of integration are 0 to 4. The outer is the distance from the x-axis to y equals 8, so that's 8. And the distance from the x-axis to the parabola is the equation 1/2 x squared. So pi r squared minus pi r squared dx. I would suggest you pull the pi out. You know, it's tricky, but practice using your calculator and see if you get the answer that I got, okay? And then u cubed, that means cubic units because we're dealing with volume here. Okay. Number 2 is the volume around the y-axis. Now what you have to do, remember that when you're revolving around the y-axis, you have to solve for x. So in other words, because you're going this way, okay, you have to solve for x. So the original parabola is y equals 1/2 x squared. Multiply both sides by 2, and then take the square root. So that's where you get that this distance right here is radical 2y. Okay? And now the limits of integration are going to be on the y-axis, and it's essentially a disk. It's going to be like this bowl shape, if you will, as I rotate it around the y-axis. Set up the limits of integration. Now this should make some sense. The volume around the y-axis is the integral from 0 to 8 of pi r squared. And instead of writing dx, you're going to write dy. Again, a lot of you made this mistake on the homework, so I do need to correct that as well. Again, I would pull out the pi because that's a constant, and radical 2y squared is 2y. Now, when you type this into your calculator, you're allowed to type in 2x. I know that's something tricky, but you can type in 2x dx, and you just know it's 2y dy. That makes sense. See if you get the answer 64 pi. The third question is the volume around the line x equals 4. Now, again, x equals 4 is a vertical line. So, like the y-axis, so again, you have to solve for x. So going back to the original picture, I have to solve for x here. So from the previous problem, x equals radical 2y. Okay? Now, when I revolve around x equals 4, I'm getting a washer. Again, that shape, okay, is a washer shape. And if this is radical 2y, the distance to x equals 4 is 4 minus radical 2y. And that's the tricky part here. So if you look at this answer, the outer is the distance from x equals 4 to the y-axis, which is 4, and then the inner is 4 minus radical 2y squared. Don't forget it's dy. Again, pull out the pi, and this is what you're going to type into your calculator. Type this into your calculator, and type in x instead of y, even though you mean y. I know that's a little bit tricky to do virtually, but use your calculator and see if you get the answer. You should get 106.667, and then you bring back the pi. That's how you do that problem. And the last question is the volume around y equals 8. Now, y equals 8 is a horizontal line like the x-axis, so you can solve for y. In other words, I go back to the picture here, and I can use y equals 1/2 x squared. Now, this distance is 1/2 x squared, so the distance to y equals 8 is 8 minus 1/2 x squared. And when I rotate that around y equals 8, I get that bowl shape this way. So it is a disk, and I can set the integral up this way. So see if that makes sense. And again, pull the pi out and use your calculator and see if you get that answer. And that would be my suggestion for the first problem. And that should help you out. I'm going to do some problems from the text that require you to solve for y and x, because I think that that's where people made a mistake on the homework that I did for you. So that's kind of where we are right now. All right? All right? So, you know, just like, let's just pick a simple one out here. And again, it's not necessarily going to be from the book, but if I have a line like, let's say I want to find the volume, let's say this is y equals 2x, and this region, it goes from 2 to 4, okay? So if I wanted to find the volume around the x-axis, that would be this way, and that would be a simple disk. Pi times the integral from 0 to 2 of 2x squared dx. That would be a very simple problem. If I wanted to find the volume around the y-axis, now I'm dealing with a washer, but because I'm revolving it around the y-axis, I have to solve for x. And then the limits of integration are on the y-axis. So the integral limits are now 0 to 4. The outer squared is going to be the distance from the y-axis to the outer, which in this case is 2, and the distance to the inner is going to be 1/2 y squared. So that's kind of the difference between the two types of problems. And again, I think that that's where the mistakes were generally made, but I will say that that's a tricky part to volume. So at this point, I'm kind of going to wrap this one up. I want you to look at this video. I'm going to put something together from the homework that was some incorrections, and maybe you can correct it. But as long as you submitted the work to me, I'm going to give you full credit. Okay? So that's all I have for now.